Welcome to the second video. This is about relationships between stuff. We probably want to take a gander at this lovely little family tree, because this is going to inform a lot of the answers to these problems. You should have that down pretty pat by this point, and if you don't, take a few minutes and memorize it, because you do need to know what goes where. So diagonals of a rhombus are perpendicular. Always, because diagonals of a kite are perpendicular, and that's just going to flow from there. Number 2, all squares are rectangles. What things are? Go up. So, if it's below, then it's above. Again, think like the flow of water. If you start something in a square, will it pass through a rectangle on its way up to quadrilateral? And the answer is, yeah, it will. If parallelogram is a rhombus, then the diagonals are congruent. Congruent diagonals come from isosceles trapezoid, so this is the part of the diagram that have congruent diagonals. Rhombus may be in that part if it's a square, but it's not always going to be a square. So, sometimes. Parallelogram is a quadrilateral. Oh yeah, every single time. Rhombus has exactly one pair of parallel sides. Well, no, a rhombus is a parallelogram, so it's never going to have just one pair of parallel sides, because all parallelograms have two pairs of parallel sides. Each diagonal of a rectangle bisects a pair of opposite angles. Angle bisecting comes from the kite, so it's on that side of the diagram. A rectangle might be on that side of the diagram if it's a square, but it's not guaranteed to be a square, so that's a sometimes. If quadrilateral is both a rhombus and a rectangle, then it is a square. Yes, that's how this thing works. If it is both of these, then it will be the square. Both pairs, I'm going to assume that what I meant to type was pairs and not pairs, because an isosceles trapezoid does not have that kind of pair, because it's a verb. So both noun pairs, base angles in an isosceles trapezoid, are congruent. Yep, the top pair and the bottom pair. There we go. Nice job. Let's get to the fun stuff. What is this thing? Hey, first thing that really need to ask yourself is it a parallelogram? But number 15, hey, we have all four sides congruent. Where do we have all four sides congruent? Oh, rhombus. And then we're going to follow the rhombus up every single way we possibly can up to the top. We're going to go through parallelogram and trapezoid, and we're going to go through kite. Again, think of this like the flow of water. If you put water in here, where will it go before it comes out here? Number 16. I don't know what this thing is, so I'm going to see if I can't prove it's a parallelogram. Do we know anything about opposite angles? No, doesn't look like it. Do we know anything about opposite sides? No, and we can't prove the triangles are congruent, because here we have any two of these triangles, we have angle side, which will not prove anything about that. So we can't get parallel either, because we can't get the other angles. So it is definitely not a parallelogram. Well, rather, we are not sure. We cannot be sure it's a parallelogram. Which means let's check about isotrap and kite. I'm not seeing any parallel lines, and like I said with parallelogram, it's not really easy to prove there are parallel lines. But oh wait, kite maybe, because we do have an isosceles triangle right here. And another isosceles triangle right here. Why? Because anything that is an altitude that is also a median means that it is part of an isosceles triangle. And since it's an isosceles triangle top and bottom, We know it's a kite, which means it's also a quad. Number 17, it's not jumping out to me as anything. The right angle suggests maybe rectangle, the congruent side suggests maybe kite, but let's figure this thing out. The first thing is, can we prove parallel lines? And it doesn't look like it. And can we prove any other angle is a right angle? And I'm thinking it doesn't look like it. Another question you can ask yourself is, could you draw this thing better and not have it be anything very specific? So could I draw a right angle? And I'm purposely going to make these sides different lengths. And then I'm going to try to draw two other sides that are the same length. And does this have to be anything in particular? And the answer is no, this is just a quadrilateral. Number 18, we have two sets of opposite sides parallel. That is one of the 6 things that you need to know will make a parallelogram. And since it is one of those 6 things, it is probably not going to be anything lower than that. But you're welcome to look. Do you have diagonals perpendicular, angled bisectors, or congruent non-opposite sides? Not number 18. Do you have perpendicular sides or right angles in the corner? Do we have congruent diagonals? Nope, so it's not a rectangle, therefore it's not going to be anything below parallelogram, and thus it cannot be anything to the side of parallelogram. It's just parallelogram, trapezoid, and quadrilateral. Number 19, we know lots of stuff about diagonals here. So the first question to ask, is this a parallelogram? Do the diagonals bisect each other? Well, no, they cut each other in the same lengths, but it's not crossing through at the midpoint because this side and that side are not the same length. So it is not going to be a parallelogram. So the question is it a kite or an isosceles trapezoid? Well, the diagonals are congruent, which, because they have 3 tick marks on them each. So we're leaning towards isosceles trapezoid. But let's see if we can't figure out anything else. You know, that's an isosceles triangle. And this triangle is side angle side similar to this triangle. So these sides, those angles are also congruent, and they're congruent to the angles on this triangle. And that makes parallel lines because we have our nice alternate interior angles. So therefore, we do have a pair of parallel sides. So we know it's a trapezoid. We know that it's a trapezoid with congruent diagonals, so we know it's an isosceles trapezoid. Therefore, it's also a quadrilateral. Of course, everything that we're going to be looking at is also going to be a quadrilateral. The question is it a rectangle? And we could do a little chapter 2 logic to find that out. We know that if it is a parallelogram and an isosceles trapezoid, then it's a rectangle. And if it's a rectangle, it is both a parallelogram and an isosceles trapezoid. So we can set up a little truth table in our head to go false, true, and false and true implies false. Therefore, it is not a rectangle. It is just an isosceles trapezoid, a trapezoid, and a quadrilateral. Number 20. You're looking at that, and hopefully it's jumping out at you. Go, wow, all those sides are the same. Oh, rhombus, that's the one where all sides are the same. That's the definition of a rhombus. Awesome, you're right. So therefore, it's also a parallelogram, trapezoid, quadrilateral, and kite. But then you're like, wait, but if it's a parallelogram and it has a right angle in the corner, then it has to be a rectangle. And you're also right, which means it has to be an isosceles trapezoid. And because it's a rhombus and a rectangle, it's a square. So we're going to list them all. It's a quadrilateral, a kite, a trapezoid, an isosceles trapezoid, a parallelogram, a rhombus, a rectangle, and a square. Number 21. Alternate interior angles. That's helpful because that makes these sides parallel. But that's all we can actually figure out. We cannot prove these triangles are congruent because we have side angle. and that doesn't tell us anything. So it's not looking like we're going to get down to parallelogram, but we already know it's a trapezoid because one set of sides is parallel. We just don't know about the other set. So we can guarantee that this is a trapezoid and a quadrilateral, but that's it. Number 22. We have two angle bisectors. It's not jumping out as a parallelogram because we don't have adjacent angles supplementary or opposite angles congruent. So let's lean over to kite because my guess is if it's anything, it's going to be over in that direction. So ask yourself, can you prove these triangles are congruent? And the answer should be yes, because of angle, side, angle. And if the triangles are congruent, that means that these sides are congruent and these sides are congruent. And look, adjacent sides are congruent. That's a kite and therefore also a quadrilateral. Number 23, we have one set of opposite sides that is parallel and congruent, which is one of the 6 tests for is it a parallelogram, and we don't know anything else, so we're not going further down that diagram, because if it's anything else, we would have to see some more information there. Number 24. First question, is it a parallelogram? We're given stuff about diagonals. Parallelogram, diagonals bisect each other, right? Right. And hey, here they do. So this thing is definitely a parallelogram. But then we go, wait, those diagonals are also perpendicular. That's one of the ways to get from a parallelogram to a rhombus. Then you go, wait, but they're also congruent because this is a 2 tick mark diagonal, and that's a 2 tick mark diagonal. And again, you're right, so it's also a rectangle. And if it's a rhombus and a rectangle, it's a square. And that means it's everything. So that means you got to check every single box because you can't write all. That's being lazy. Number 25. There's an exterior angle of this thing, which is congruent to that. So corresponding angles are congruent, and therefore those lines are parallel. But oh wait, this exterior angle is also congruent to that. So now we have alternate interior angles making that Z shape. So these sides are also parallel to each other. Whoa, 2 sets of parallel sides. Definition of a parallelogram. If it matches the definition, I wouldn't even bother looking any further down because you're not going to find anything. 26. What is this thing? What do we know about it? It has 4 sides. That's it. End of story. Don't trust your eyes, trust the markings. We have the same kinds of questions for these problems, although it's probably going to be nicer to see these on a graph. So first thing, put them on a graph. That was easy. I'm looking at this thing and I'm saying, I don't think it's going to be a square, and I'm probably going to be right. So let's figure out, first of all, is this thing a quadrilateral? By the way, I'm also thinking it's not a rectangle because those things don't look like right angles to me. Although my screen is kind of stretchy, so who knows? We'll check for that later on. But I'm going to do the test of the parallelogram of do the diagonals bisect each other. So add the x coordinates of AC, divide by 2, and add the y coordinates of AC, divide by 2. That'll give us the midpoint of AC. Except I looked at the wrong points. So -2 plus 6 divided by 2. Or did I look at the right points? 5 plus -3 divided by 2. Oh, I did look at the right points after all. So the midpoint of AC is 2, 1, or right there. Now let's check out the midpoint of BD. So the midpoint of BD, we're going to go 4 plus -1 divided by 2, and 4 plus -2 divided by 2. And 4 minus 1 is 3 over 2. It is not going to be the same midpoint as this. So we know that A is not, we know that 27 rather is not a parallelogram, which means it's not going to be anything below it. It's also looking like it's probably not going to be a kite, but let's just double check. Is one diagonal the perpendicular bisector of the other one? Well, let's try this. That would be that line. Does that go through the, is that a diagonal? No, so it's not a kite. Next question, is it a trapezoid? And if so, what kind? So the slope of the top is over 6, over 5, down 1, and the bottom is over 6, down 1. Well, those aren't the parallel sides. What about these? 1, 2, 3, 4, 5, 6, 7, over 1, and 1, 1. Oh, it's not even over 1, so no, it's not a trapezoid, which means it's also not an isosceles trapezoid, which means this baby is just a quadrilateral. Number 28, I can already guarantee you this is not going to be a parallelogram because the top and bottom are definitely not parallel to each other. That eliminates those. Let's double check the sides because maybe it's a trapezoid. Down 2 over 3, down 3, over, here I'm going to look here, K to L, over 4. Nope, that set of sides isn't parallel either. I guess maybe it's going to be a kite, but 2 squared plus 3 squared for this side is square root of 13. And from J to K, it's not square root of 13. So again, another quadrilateral. How convenient. So you're looking at 28 and you're going, wow, negative 14, negative 10. This graph doesn't go to negative 14, negative 10. You're right, it doesn't. So let's count by 2's instead. And my guess is you're probably looking at this one and going, well, that's not going to be a parallelogram either because there's no way that those opposite sides are parallel. And I think you're probably right. But maybe one set of sides is parallel. We can also probably knock kite out of this running too. So let's just double check. Is WS parallel to, question mark, VT? So from W to S, negative 14 to negative 2 is positive 12 on the x's. Remember that goes on the bottom. And from 7 to negative 1, that is down 6, which is negative 1/2. And then let's check VT. From negative 10 to positive 2 is 12. And from 13 to 5 is negative 8. So, oh, they're not parallel, which means, wow, all of these are quadrilaterals. Not what I was intending to do, but that's how they turned out. Probably won't be that way on your test, though. I've skipped over the proofs and I've skipped over the constructions. Those are for you to work on your own. Good luck on your test.